Hey everyone! Today we're going to peek behind the curtain of the maps you use on your phone every single day. We're going to break down the simple yet brilliant system that takes our big, complicated world and turns it into those clean, interactive maps. So let's dive in.
So, have you ever just stopped and thought, how on earth does all of this, the buildings, the roads, the rivers, get perfectly squeezed onto that little screen in your hand? It's kind of like drawing an old-school treasure map, right? You need a way to put an X on the spot, draw the path to get there, and then outline the shape of the island. Well, our digital maps do something that's surprisingly similar.
And the secret sauce is something called the vector data model. It's this really elegant and powerful method used in Geographic Information Systems, or GIS. Basically, it's designed to represent discrete things in the real world. Things with clear defined edges, like a building or a road. And it does all this using a simple combo of points, lines, and polygons, all defined by specific X and Y coordinates. You can think of it as the fundamental ABCs of every digital map.
Now here's the really cool part. This whole incredibly sophisticated system, it's all built on just 3 fundamental building blocks. It's that simple. Let's break them down one by one.
All right, first up, we've got the most basic element of all, the point. It's literally like putting a pin on a map. It represents one single spot with just one pair of XY coordinates. It has no size, just a position. This is absolutely perfect for things like a single bus stop, a school, or even an entire city when you're zoomed way, way out.
Okay, so what happens when you start connecting those dots? Well, you get our next element, a line. It's just a sequence of coordinates that represents features that have length but no real area. This is how our maps draw all the networks that connect our world. The roads we drive on, the rivers that cut through the landscape, and the railway tracks that link everything together.
And finally, to complete our trio, what happens when a line loops all the way back to where it started? Boom! You get a polygon. This is a closed shape that represents an area with a clear boundary. Polygons are what we use for anything with a distinct size and shape, like a lake, a forest, or a city's boundary lines. And that's pretty much it. With just these 3 simple elements, points, lines, and polygons, we can map almost anything with a defined edge.
So we get the what? Points, lines, polygons. But why this method? Why is it the go-to for so many of our maps? Well, that all comes down to its unique characteristics, which make it unbelievably efficient and powerful.
Just take a look here. This table really lays out all the advantages. Because vector data is built on precise coordinates, it's incredibly accurate. It's also super efficient, so it takes up less storage space on your devices. Plus, as you can see, features are easy to update, and the boundaries are always crystal clear. But that last one on the list, that is a total game changer.
Network analysis. This is the magic behind so many of the apps we use every single day. Because the vector model inherently understands how lines, like roads, are connected at points, like intersections, it's perfect for calculating the fastest, most efficient route from point A to point B. So the next time your food delivery app finds that perfect shortcut to your door, you'll know that's the power of vector data at work.
All right, so let's tie all this together. Why does this model really matter? What's the big picture here?
This quote from our source material really just nails it. The vector data model is what gives us this hugely effective way to map all the distinct individual features of our world. It's how we translate the physical reality of roads, cities, and borders into clean, digital information that we can actually analyze and understand.
So here's a little challenge for you. The next time you open up a map on your phone, don't just see a map. Try to see the vectors behind it. Look for the points that represent stores. Trace the lines that make up the streets, and spot the polygons that define the parks and neighborhoods. You'll start to realize the world on your screen is just made of vectors, if you know how to look. Thanks for joining me for this explainer.